Imagine a world shrouded in eternal twilight, where the sun hides behind a veil of ash so thick it turns day into endless night. The air chokes with sulfur, rivers run black with poison, and the once vibrant pulse of life fades to a whisper. This isn't the plot of some dystopian fable, it's a memory etched into our very DNA. A cataclysm that clawed at the roots of humanity 74,000 years ago. And as we gaze into the stars tonight, we must ask, what if it happens again? What fragile thread holds our species from the brink of oblivion? Picture the Earth in its ancient splendor, a blue marble teeming with early humans wandering across vast savannas, forging tools from stone, and dreaming beneath the unscarred sky. Our ancestors, Homo sapiens, had only recently begun their exodus from Africa, spreading like fragile seeds on the wind. They numbered perhaps in the hundreds of thousands, their lives intertwined with the rhythms of nature, hunting mammoths under golden sunsets, gathering berries in lush forests, and huddling around fires that warded off the chill of the unknown. But beneath their feet, the planet harbored a secret fury, a colossal beast stirring in its sleep. In the heart of what we now call Sumatra, Indonesia, lay Lake Toba, a serene body of water today. But once the cradle of apocalypse, this was no ordinary volcano, it was a supervolcano, a geological titan capable of unleashing energy equivalent to billions of atomic bombs. When it erupted, the world didn't just shake, it shattered. The eruption began with a rumble that echoed across continents, a deep groan from the Earth's core as magma chambers, swollen with pressure, finally gave way. In an instant, a column of superheated gas and rock shot 30 miles into the stratosphere, piercing the heavens like a dagger. Ash billowed out in incomprehensible volumes, enough to bury entire cities under feet of gray death. The blast wave alone pulverized everything within hundreds of miles, turning forests to splinters and lakes to boiling cauldrons. But the true horror unfolded in the days and months that followed. The ash cloud spread like a cancerous shadow, encircling the globe, blocking sunlight and plunging the planet into a volcanic winter. Temperatures plummeted by degrees that seem modest on paper, perhaps 10 to 15 Fahrenheit globally, but in reality, they spelled doom for ecosystems everywhere. Crops failed before they could sprout, animals starved as grasslands withered, and rivers, clogged with debris, became undrinkable sludge. Our ancestors, scattered and vulnerable, faced extinction's cold stare. Genetic evidence whispers of this nightmare, a bottleneck in human diversity, where our population plummeted to as few as 3,000 to 10,000 breeding pairs. Imagine the survivors huddled in caves, their skin caked with ash, eyes stinging from acrid fumes, watching as kin succumbed to famine, disease, and the relentless freeze. Mothers cradling infants who grew weaker by the day. Elders recounting tales of a warmer world that now seemed like myth. The skies remained darkened for years, perhaps up to a decade, as sulfuric aerosols lingered in the atmosphere, reflecting sunlight back into space and amplifying the chill. This wasn't just a local tragedy, it was a global reset, altering climates from the African plains to the Eurasian steppes. Sea levels fluctuated, monsoons weakened, and megafauna, those colossal beasts that once roamed alongside us, began their slow march toward oblivion. Yet, amid this desolation, humanity clung on, adapting through ingenuity and sheer resilience. They migrated to pockets of refuge, perhaps coastal areas where seafood sustained them, or equatorial zones less ravaged by the cold. Their survival wasn't guaranteed, it was a razor-thin victory against the cosmos' indifference. But how do we know this tale isn't mere legend? Science peels back the layers with quiet precision. Core samples from ice in Greenland and Antarctica preserve the eruption's fingerprint spikes in sulfate levels dated precisely to 74,000 years ago. Lake sediments around the world hold shards of Toba's unique volcanic glass, carried on winds that knew no borders. And our genomes tell the most intimate story, mitochondrial DNA, and why chromosome markers reveal a sudden narrowing of genetic variation. An echo of that near-extinction event. It's as if our ancestors passed through a sieve, leaving behind a homogenized legacy that we all share today. Questions swirl like the ash clouds of old. Why did Toba erupt with such ferocity? Supervolcanoes farm over hotspots or subduction zones, where tectonic plates grind and melt rock into magma, reservoirs the size of small countries. Toba's caldera, now filled by that tranquil lake, measures over 60 miles long, a scar so vast it's visible from space. The pressure builds over millennia, until a trigger, perhaps an earthquake or a fresh influx of magma, unleashes the pent-up rage. As we delve deeper, the mystery thickens. Could such an event recur? The Earth is dotted with these slumbering giants: Yellowstone in North America, Campi Flegrei in Italy, Taupo in New Zealand. Yellowstone alone has erupted cataclysmically 3 times in the last 2 million years, each blast reshaping the continent. Its magma chamber, monitored by seismographs and GPS, shows subtle swells and quakes, harmless for now, but harbingers of potential unrest. Scientists model these eruptions using fluid dynamics and geochemistry, simulating how gas bubbles in magma reduce its density, propelling it upward in a runaway feedback loop. Visualize it beneath Yellowstone's geysers and hot springs. A sea of molten rock seethes, heated by the planet's radioactive decay and mantle plumes. If it were to erupt today, the initial blast would vaporize everything within a 50-mile radius. But the ash billions of tons would blanket the Midwest, crippling agriculture and plunging global temperatures by several degrees for years. Famine would stalk civilizations, supply chains would collapse, and the economic toll could eclipse trillions. Yet, the probability is low, perhaps 1 in 700,000 years, but not 0. It's a cosmic lottery we play unwittingly. Before we step further into the unknown, take a moment to subscribe to Future Lens so you and I can keep exploring worlds beyond time, space, and imagination together. Now, let's widen the lens to the broader canvas of existence. What if Toba wasn't an isolated fluke, but part of a larger pattern in the universe's grand design? Consider the ripple effects that eruption may have accelerated human evolution, forcing our forebears to innovate sharpening tools, mastering fire more adeptly, or even fostering early social bonds that laid the groundwork for civilizations. In the genetic crucible, survivors carried mutations that enhanced resilience, perhaps bolstering immune systems or cognitive adaptability. But peering ahead, the specter of recurrence looms larger in our interconnected world. A modern supervolcanic event wouldn't just echo Toba, it would amplify it through our fragile global networks. Air travel grounded by ash clouds denser than any storm. Satellites blinded. Power grids faltering under electromagnetic pulses from the ionized atmosphere. Billions could face starvation as croplands lie fallow, and pandemics might surge in the chaos of displaced populations. Scientists at observatories worldwide track these threats with arrays of instruments, infrasound detectors, catching the Earth's subtle grumbles. Satellite imagery revealing ground deformation. Volcanic explosivity index rates these beasts at 8, the highest level dwarfing even the infamous 1988 eruption of Mount Pinatubo, which cooled the planet by half a degree for months. Yet, the deeper enigma beckons. Are we alone in this vulnerability? Or does the cosmos teem with similar scars? Exoplanets, observed through telescopes like Hubble and James Webb, show volcanic activity on worlds like Io. Jupiter's moon, pocked with eruptions that paint its surface in sulfurous hues. Imagine alien civilizations, if they exist, navigating their own apocalyptic hurdles, gamma-ray bursts sterilizing atmospheres, or asteroid impacts like the one that felled the dinosaurs 66 million years ago. Our Chicxulub crater in Mexico serves as a reminder, a 10-mile rock slamming into Earth at cosmic speeds, igniting wildfires worldwide and acidifying oceans. Humanity dodged that bullet by eons. But the asteroid belt and Oort cloud still harbor potential harbingers. NASA planetary defense initiatives, like the DART mission that successfully nudged an asteroid in 2022, offer glimmers of hope. We're learning to deflect these celestial threats. But supervolcanoes defy such intervention. Thea woven into the planet's fabric. Climate models integrate these scenarios, blending volcanology with atmospheric science to predict ash dispersal patterns driven by jet streams and trade winds. In one simulation, a Yellowstone eruption could drop North American temperatures by 20 degrees, triggering ice age-like conditions and shifting monsoon patterns that parch Asia's breadbaskets. Tension builds as we contemplate the hidden truths. Earth's history is a litany of near misses. The Permian-Triassic extinction 252 million years ago, dubbed the Great Dying, wiped out 96% of marine species through massive Siberian traps volcanism, flooding the atmosphere with carbon dioxide and methane, acidifying oceans and scorching lands. Echoes of that persist in our fossil records, layers of coal and basalt testifying to prolonged eruptions. Could anthropogenic climate change awaken these giants prematurely? Rising temperatures might destabilize permafrost, releasing gases that lubricate fault lines, or alter pressure in magma chambers. It's a feedback loop of our own making, where human hubris intersects with geological inevitability, visualizing the future cities enveloped in perpetual dusk, refugees streaming across borders, scientists in bunkers racing to geoengineer solutions, perhaps seeding the stratosphere with aerosols to mimic the cooling effect, ironically echoing the volcano's own mechanism. As we approach the horizon of this journey, the awe deepens into something profound. Humanity's story is one of improbable persistence, a fragile flame flickering against the void. We've risen from the ashes of Toba, building empires, unlocking the atom, and reaching for the stars, all while the ground beneath us simmers with ancient fire. This event, etched in stone and sinew, reminds us that we are not masters of the earth, but fleeting guests in its tumultuous saga. In the quiet of night, when the wind whispers through trees that outlived our ancestors' trials, we feel the weight of what could come again. Yet, in that vulnerability lies our greatest strength, the spark of curiosity that drives us to monitor, to prepare, to dream beyond disaster. And so, as the embers of that ancient cataclysm glow faintly in our collective memory, let us ponder in the grand theater of the cosmos, where worlds are born and die in silence. What if our survival is not a guarantee, but a poetic defiance, a single, luminous thread weaving through the darkness, daring the universe to try again?